Welcome back, grade 7, to another math term where we're going to take a look more at patterns and sequencing. In this lesson, though, we talked last time quite a bit about rules. What is the rule about going from term 1 to term 2 to term 3? Are we adding by a certain amount? Are we subtracting? Are we multiplying, dividing? Are we even throwing in exponents? And so today we're going to work more on creating or figuring out some of those rules. So to start, let's consider a particular pattern. And the pattern that we're going to take a look at is one that we started with last time, which is the pattern of 1, 3, 6, and 10. If you remember, that was our pattern with the dots, where we increased by 2, by 3, by 4. So in understanding that, we can think of how term 1 is just simply 1. Term 2 starts with that 1 and adds 2 more to that to get to our 3. Term 2 is originally what we had before, that 1 plus 2, and then we add 3 to that one. Term 3 is that 1 plus 2 plus 3, and then now we're going to add 4 to that one here. So we're increasing, or we're doing some different things as we go through, and as we try to figure out what our term is going to be. What we want to be able to do is come up with some sort of formula so that we can figure out what Tn is, the nth term. And that might be term 16, that might be term 116, term a million, that we're able to come up with some sort of formula where we plug in the value for n, whatever term number we want to find, and we're able to figure out the value at that term number. This one here is a little bit tricky. I'm just going to give this one to you, and then we'll work on creating our own in a little bit. It's basically going to be 1/2 n, or n divided by 2, times n plus 1. So because of that, this is a bit of a trickier formula. Don't stress too much about this one. But if I were to try to figure out term 6 for this question, all I would do is wherever I see n, I replace it with the number 6. So I would do 1/2 times 6 times 6 plus 1, which would equal 1/2 of 6 is 3, times 6 plus 1 is 7, or 21. That would give me the value. So in other words, at term 6, there would be 21 dots. It's a lot easier than having to draw out this picture multiple different times as we go through. And it's this sort of formula that we're going to be creating. We're also going to learn in a little bit how we can take one of those formulas, figure out the term number there, how we can create our own formulas, and then how we can also work with some of these things in order to figure out some word problems. So that's just a quick explanation of some of the things we're going to be going through. We're going to be diving now into some of the examples. If you'd like to stick around and hear the bigger explanation of examples, feel free. If you'd like to take a look at them on your own, you're welcome to do that as well, and to stop the video here. Example number 4 is our first one, and it says that the general term of a sequence, Tn, is n squared plus 2n minus 1. So it's a pretty complicated formula. Thankfully, we didn't have to come up with it. We're just given it. And it asks us to find the first term and the 10th term. First term and the 10th term. In other words, what they're looking for is T1 and T10. So if I know that it's the first term, then I know that my n is 1. If I know that it's my 10th term, then I know that my n is 10. So I'm just solving this question, replacing n with 1 the first time, and replacing n with 10 the second time. So let's go through and see if we can solve that. So n squared would be 1 squared now, plus 2n would be 2 times 1 minus 1. So order of operations here, I do my exponents first. 1 squared is 1, plus, next I do my multiplying. 2 times 1 is 2, minus 1. Running out a little bit of room here, let's go over here. 1 plus 2 is 3. 3 minus 1 is 2. So my first term is 2, or t1 equals 2. t10 equals 10 squared plus 2 times 10 minus 1. 10 squared is 100, plus 2 times 10 is 20. 100 plus 20 is 120 minus 1, which is 119. So the 10th term is 119. All we needed to do here was plug in the values, or substitute in the value for n, whether it was the first term, the 10th term. We could have done this for the 85th term, and then n, we just would have plugged in the number 85, and we would have been able to figure it out using that particular formula. You're going to be doing the same thing in Try It 4, but using a different formula to figure out the second term and the 9th term. So that's if we're given the term, but what if we're not given the term? Well, let's take a look at example 5. Example 5, we're given a sequence, and we're asked to start by finding the term. So the sequence that we're given is 4, 10, 16, and 22, ... It continues on, but that's all that we're given in order to try to figure out a pattern. Now this one gets a little bit tricky. If I take a look at it, I see that each time around I am adding to the pattern, and I'm adding 6. And that's good, and we dealt with that last time, that we can pretty easily maybe figure out term 5 and term 6. But if I asked you to figure out term 217, it would take an awful long time to be able to do that without a formula. And so we're going to want to figure out a formula, or what the textbook calls a general term, for this question. So in order to have a general term, we know that we're going to be adding 6 to something, and we know that our starting value, or our starting number, is 4. So we're going to be, whatever our starting value is, we're going to have that number there, and when we're adding, we're going to be adding 6 to that starting number. Now we want to incorporate, though, our value for n. Now this is where things get a little bit tricky. Do we, for our first term, do we add 6 to our first term to get to 4? No, we don't. We just add 6 to our second term, our third term, our fourth term, in order to keep going. So by the third term here, we've added how many 6? Two 6s. By our fourth term, we've added 3 6s. So we always add 1 less 6 than the term number that we're on. So if we're on term 17, we're adding 16 6s. If we're on term 245, we're adding 244 6s, just 1 less. So it's 4, our original number, plus 6 times the term number minus 1. 1 less than the original term number. This formula that we've just created gives us what we call our general term. Another way to find the general term is to simply write it out. So t1 equals 4, t2 equals 4 plus 6 now, t3 equals 4 plus 6 plus 6, t4 equals 4 plus 6 plus 6 plus 6. So if we take a look here, we see that we're beginning to develop a pattern. We could also say this is the same as 4 plus 6 times 1, 4 plus 6 times 2, 4 plus 6 times 3. And hopefully we're beginning to see that the only real thing that's changing is this multiplication value. And it's increasing by 1, but it's 1 off from the term number that we're at. So that's another way that you could generally take a look at that to create the general term. We would therefore say that the general term of Tn is 4 plus 6n minus 1. That's the general term, or the general rule that helps us follow this particular question. Part B of this says, hence, find its 25th term. Okay, so 25th term means that my n is going to be 25. So 25th term is going to be t25, and it's the same formula, 4 plus 6, 25 minus 1. So at T25, I have 4 plus 6, order of operations first, so brackets first, times 24. Next, or 25 minus 1 is 24. Next, 6 times 24 is what we need. And so 6 times 24 is going to give us a value of 144. So T25 is going to be 148. So it's a quicker way for us to figure that out. If we had to constantly add 6 on and constantly write out all 25 terms to figure that out, that would take us much longer. This is a much quicker way to be able to do that particular question. All right, let's take a look now at example 6. Our final example here, which is a little bit trickier. It deals with the dot pattern, and it deals with a dot pattern that is maybe not as friendly as we continue to figure out how this dot pattern increases. So the dot pattern for example 6, it starts off with 2 dots, then it has 6 dots, then it has 12 dots, and it continues to increase. So T4, our fourth term, is a square that is a 4 by 5 square, or 20 dots. Okay, so this, our n is 1, our first term, our n value is 2, our second term, third term, fourth term. At first we're asked to figure out, to find the general term in this sequence. So let's start by identifying what we know. So T1 is, it gives us a value of 2. And we can think about this in terms of a square, in terms of a box. So it's really a 1 by 2 box. T2, we increase the height by 1 and we increase the width by 1. So this one is now a 2 by 3 box. T3 is a 3 by 4 box, and T4 is a 4 by 5 box. Hopefully you're starting to see a little bit of a pattern here as we begin to shape this up, as we begin to go through. And so Tn, if I continue through this same pattern, what do you notice about our first numbers? Well, we go 1, 2, 3, 4, and it actually matches the exact same term number. So instead of writing that as a number, we can actually say that Tn is the same as n, because 4 matches 4, 3, 3, 2, 2, 1, 1, times, now what can we say about this one? This also increases by 1, but it's always 1 more than the term number. So n times n plus 1. And now I've been able to create the general term for this dot pattern to be able to continue to solve this question. Part B of this one then says find T17. Okay, well that's nice and easy to do. I know from looking at this that it's actually going to be a 17 by 18 box. And so if I follow the pattern T17, n is 17 now. It's going to be 17 times 17 plus 1, or it's going to give me a box of 17 by 18. All I have to do is multiply those two values together to figure out that that box is going to have 306 dots in it. An awful lot easier than having to draw out all those dots multiple times as we go through. So just as a reminder, try it 5 is going to be exactly like example 5, and try it 6 is going to be just like example 6 as you go through and figure out those types of dot patterns. And as we go through, as we solve some application problems by observing the number patterns and generalizing them to find the general term of a sequence, we're going to be getting into some where we have a little bit more word problems that we're going to work with. And when we're working with word problems or problem-solving strategies, there's kind of 4 key things that we want to remember. First, you want to try to understand the problem. What's it asking? What's it trying to get at? What are we asking to solve? 2, we want to look for a pattern. And sometimes that pattern might be pretty simple and pretty obvious. Sometimes it might be a lot more complex. If you need to, feel free to draw pictures or figures to gain some insight if that might be helpful, to be able to visualize it a little bit better. 3, you want to generalize the results that you get. So generalize, this is coming up with a general term, coming up with a rule that fits for all cases that we're going over. And 4, look back and check, does it make sense? Does the answer seem to fit with the question that you were given? And it's important to be able to validate that as you go through these particular types of questions.